First of all, movie buff. Who knows the reference? Come on. I love the smell of NPM in the morning. Oh, God, you're so young. Look it up. Okay. What are the 3 biggest trends in JavaScript in the last 10 years? That's my opinion. Modern UI frameworks, React, Vue, Angular, stuff like that. JavaScript tooling, I hate JavaScript tooling, but we need it. Transpilers, bundlers, linters, minifiers, right? And the most important one for this talk is TypeScript. Ooh, TypeScript has been conquering the UI world, the front-end world. And this talk is about a formal proposal for enhancing JavaScript that forever will change how we view number 3, impact number 2 significantly, and will probably do a lot for number 1. This is a proposal for TC39 that will change JavaScript development forever. A proposal, come on, give me, for adding types to JavaScript. Oh, right. Okay, hi, I'm Gil Tayar. I'm old, all the way back to the 80s. I know what MS-DOS is. Like Neta before me, I'm an individual computer. I love it, but at this age, I can't say I'm a software developer, so I say I'm a software architect. I am currently an architect at Roundforest. Obviously, we are hiring. I am also a member of the group that is writing this proposal. This is a dream for me. I mean, I always wanted less tooling. I always wanted to remove transpilers. And suddenly becoming a part of the group that is trying to remove at least TypeScript transpiling is for me a dream come true. Joining people like Daniel Rosenwasser from Microsoft, Little Dan, and Rob Palmer. I mean, these are giants at TC39, and joining them and writing and co-authoring this proposal was for me a dream come true. And as I said, I was the original author with guidance from Little Dan. The opinions are absolutely mine. They are not necessarily of all the members of the proposal. A lot of members, we have different opinions on some stuff. These opinions are mine, so please take them with a grain of salt. They're definitely not my employers. And I was asked by the TypeScript team to add the last one. I do not speak on behalf of the TypeScript team, okay? So, also, the proposal is officially part of TC39, which is the JavaScript standardization committee. It will get heavily shaped by the whole process, so it will probably not look like what I'm showing. It will probably be heavily changed, so no guarantees here. And this talk will be about this proposal. Where was it proposed? What is it? And why? And the important thing is why. Okay, ooh, yeah, I get what Kenzie Dodds was talking about. The where, TC39. What is TC39? Where it was proposed. TC39 is a committee for the standardization of general-purpose cross-platform vendor-neutral programming language, ECMAScript. And why is it not called JavaScript? It's thanks to a company called Oracle, and then before that Sun, who holds trademark for JavaScript, but ECMAScript, JavaScript, same. Basically, all the new features you get in JavaScript are standardized by TC39. The process is very, very, very transparent. They have meeting notes, everything really amazing. I'm probably one of the few that reads meeting notes like religiously, but if you want to, this is the GitHub repo. And each year comes a new version of JavaScript. JavaScript ECMAScript 2022 just came out, by the way, and it gives things like and includes an async await and top-level await and things like that. That is what TC39 standardizes. And it's a process. It goes through stages. So stage 0 is where I want to propose this to TC39. We just write the spec, or we just write a proposal. Stage 1 is where they meet. They meet every 2 months, I think, and discuss the proposal. And if they say, interesting, then it gets to stage 1. Stage 1 is just, interesting. They're not obliged to accept it. Stage 2, we start writing the spec, like really into the details. And if they accept it, then it's at stage 2, where they say, okay, this is good, this looks interesting, let's iron out stuff. Stage 3 is waiting for implementation. All the little details have been ironed out. And now at least two JavaScript runtimes have to implement it. Usually Chrome V8 and others, Safari and Firefox, they all have JavaScript runtimes. They implement it. At least two need to be implemented. And if everything is fine, it gets to stage 4. Sometimes things roll back. I think the most interesting was annotations. Like at something, it was at stage 3, went back to stage 2, went back to stage 1, goes up, and it's doing a journey. Okay, that's TC39, and that's where we are at. What is the proposal? The types annotation proposal was proposed on March 31st. That's basically April. And obviously it wasn't proposed on April 1st because people would have thought it was a joke. Really, it's immense, and it was accepted incredibly enough, accepted to stage 1. So the committee expects to devote time to examining the problem space. Okay, so it's acceptance of the problem space, not specifically the solution. Okay, let's talk about the proposal. Let's give a brief draft, and then we'll go into the details later. But let's see what it is. This is JavaScript code. Everybody knows add A, B, return A plus B, very simple function. And this is the same code with type annotations. This is what the proposal says. This proposal says that this code will run in JavaScript without any transpilation whatsoever. This is the type annotations. Everybody knows what the syntax is, right? What is it? Type. There we go. Will this pass? Okay, there's add to, sorry, it should be add to in two places. So I'm passing a string and I'm passing a Boolean and it's supposed to be accepting numbers. Will this pass? Yes, it does. TypeScript, not TypeScript, type annotations will be ignored by JavaScript. They will not be processed. From the JavaScript runtime's point of view, those are comments. The original proposal, by the way, was called types as comments. That was the original proposal. Let's give types, but have the JavaScript runtime treat them as types. We'll talk about the why later, but just accept it as it is. Thus, these are also legal annotations, type annotations. Is this TypeScript? No. But from the JavaScript runtime's point of view, this is fine, okay? The TypeScript annotations here are fine from that point of view. The JavaScript runtime will ignore it. Obviously, TypeScript will say, well, there's an error here, and Flow and other type systems will say there's an error here, but from JavaScript point of view, it's fine. So basically what we're doing is we're carving out a space in the JavaScript syntax where we're saying, this part, just ignore it. It's for types. Just totally ignore it. You don't care what's in there. More type annotation spaces. We've seen like parameters and the types and type annotations on parameters. More are things happening after the type. Type something equals, JavaScript will ignore it. Yeah, that's about it. So we're basically defining a type annotation syntax space that JavaScript runtime will ignore. Interestingly enough, well, obviously, it by chance corresponds to the same areas that TypeScript and Flow have for their type systems. So basically, 95% of TypeScript programs will run in JavaScript, assuming this proposal is accepted. I will stop saying assuming if this proposal is accepted, okay? It may never be accepted, but let's assume for this talk that it is. So if this proposal is accepted, then TypeScript programs, most of them, and we'll talk about the exceptions later, will just run without any transpilation. And obviously, we didn't choose those type syntax annotation spaces by chance. They were chosen because we looked at TypeScript, we looked at Flow, and we looked at Hegel, which is another type system, and chose them according to those three and probably others. But this is not TypeScript. This is legal JavaScript if this proposal is accepted. Okay? Fine by JavaScript, not fine by TypeScript, not fine by Flow, but fine by JavaScript. Wait, you're asking yourself, why add type annotations if they are ignored? I mean, what's the point? And the answer is, I hydrate. This is React. I dehydrate a lot. So, because TypeScript and Flow, third-party type checkers like TypeScript and Flow will not ignore them. They will read the code and, based on that, show errors. Okay, so we still have TypeScript showing the errors and showing the and having the errors, but JavaScript runtime will ignore them. Okay, so the proposal, the summary, like first draft, we'll talk about the details later, is the proposal reserves a syntax space for type annotations, which are ignored by JavaScript, which are ignored by the type runtime, but are assumed to be checked by TypeScript, Flow, and other type systems, and by chance, not really by chance, correspond to the same places in TypeScript and Flow that they already have for type annotations. Okay, we announced the proposal on March 9th, before we submitted it, and the internet exploded. I mean, I've never seen a proposal for TC39 get this much recognition, and I mean, lots of finally and yes, and woo, and all that. Obviously, this being the internet, there was a lot of criticism. Most of it okay, good criticism, not things we didn't think about, obviously, but good criticism. And some of it was like really ugly because internet. But I will be talking about the criticism here. A lot of this will be talking about the why and answering those critics. And which brings us to the why. Why add types at all? Okay? This is not a trivial feature. I mean, adding type annotation syntax space for JavaScript is not trivial. It's not .at or includes for string, right? It's not simple. So for a feature this size, the benefit to all of us has to be substantial. And I give two graphs as an answer. This is beautiful. This was given after we proposed and somebody sent me this. Look at that. This is pull requests in GitHub, March 2022. All of them, grouped by language. Obviously, JavaScript and TypeScript are like most of them, because we rule. No, seriously. But most of us are there. And look at this. If we look at JavaScript and TypeScript as JavaScript, and I tend to look at it this way, then almost half of the PRs, of the pull requests that we all are creating in open source and other projects are TypeScript today. That's amazing. Not JavaScript, TypeScript. The JavaScript community, and this is like proof, is using TypeScript heavily for its code. This is not like some idea of mine or an opinion. This is based on data and facts. Type annotations are used in the field and have probably proven their value. If they haven't proven value, we wouldn't be using it. State of JavaScript 2020, what do you feel is currently missing from JavaScript? Static typing is like by far the biggest. It gets less in 2021, God knows why, but it's still number one. So people want static typing. A large part of the community wants static typing. So is it worth the complexity? Well, yeah, if almost half of the PRs are using type annotations, then I say yes, it's worth it. 3 more reasons not to add types to JavaScript. Types are difficult for beginners. Types increase the payload in web apps. And I don't like types. Types are shite. Types are difficult for beginners to grasp. It's a valid criticism. If you start from JavaScript, adding and making beginners understand types is actually difficult. But if you start from type annotations, TypeScript or Flow, then explain. I mean, my daughter, she's 15 years old. She is, God forbid, learning Java as her first language. I am so sorry for that. I have failed as a father. But she gets it. Believe it or not, she understands type, so it's not that bad. And somebody wrote on Twitter, in one of the GitHub issues, someone learning to program for the first time was spending long hours trying to install the various tools required. So if transpilation isn't needed, some of those tools will go away. And new programmers searching for example code today, new programmers are likely to find TypeScript code, and they copy-paste it into the console, and does it work? No! But if this proposal is accepted, it will. In other words, whether we want it or not, TypeScripts are part of it, and we need to get beginners to understand it. Types increase payload in apps. I don't get that. Okay, I really, so does indentations. Indentations increase payload in web apps. So does comments. Comments increase payload in web apps. That's not true, because we have minifiers, right? We have minifiers to compress our code, and minifiers can remove all the type annotations. Not a problem. I don't like types. Types are shite. I know. I was there. I moved from Java to JavaScript, and I thought the problem in Java was types. That's wrong. When I started using TypeScript, I saw the types are really, really nice. The problem is Java. It's not, but really, it's not about me. But by the way, I was known as a TypeScript denier in the JavaScript Israeli community. But it's not about me. It's not about you as an individual. It's about the community. And the community wants types. You can see that in the graphs. They just want it. Okay. I've convinced you. We as a community want type annotations, but we already have TypeScript. Why do we need to extend JavaScript? Why not just continue using tooling? TypeScript is tooling, or Flow is tooling. Why not continue? I have three answers: a philosophical, pragmatical, and political. Let's talk about the philosophical answer. We have forgotten. You've never known your roots in scripting, and you've gotten, like, you started from React, right, most of you. But me and Noam Rosenthal, and probably remember that JavaScript was originally a very simple language rooted in scripting, like Perl and Python, okay? We have forgotten our roots in scripting. Code the code, press F5 to refresh the page, and boom, it works. We've forgotten we need so much tooling today. We have become addicted to tooling, and that saddens me very much, because I like simplicity. We cannot not use it anymore. Juniors developers don't understand this tooling. They don't understand type transpilation and bundlers and all that build steps. They just don't understand it. Senior developers don't understand it. I can barely understand it. Okay, so a lot of you are using toolings and don't really know what's happening under the hood. It's not your fault. It's very, very complex. It is our fault for getting into this whole mess, but it's fine. I mean, there were good reasons for that, but we need to remove them. We need to remove those reasons slowly. TypeScript tooling is a big part of the problem from my point of view. The other philosophical one is there's a rift in the time-space continuum, not just in the JavaScript community. We're coding in one language, TypeScript, a lot of us, but running in another language, JavaScript. I mean, no other language has that. Probably yes, but mostly no. There's a growing rift, and there's a lot of the TypeScript yes, and TypeScript no, and all of that. We need to mend that rift. We need to get back together and have the code be one language. Pragmatic answer. TypeScript is everywhere. Any tooling that we have, Remix, Webpack, ESBuild, whatever, all minifiers all need to understand TypeScript because they want to deal with TypeScript natively. So these tools, unfortunately, need to evolve with TypeScript. Anytime TypeScript changes, they change their code. And that is bad because they don't really want to understand TypeScript. They just want to, they don't want to understand TypeScript. They just want to, ignore the parts of the types. And this proposal simplifies the tooling tremendously because they will have one way of ignoring it, past, present, and future, and we're done with that problem, and most tools will become simplified and not need to follow TypeScript. And the political answer, this is where it gets, TC39 should be the arena for type systems, should be arena where we talk about type systems and their place in JavaScript, and not defer it to other places where stuff can happen. It's always a balancing act, and we'll talk about that later, but TC39 should be part of the process of defining what types are. Okay, So we want types. We got it as part of the language, but this will not enable us to standardize types in the future. A lot of people got that immediately, and they're very, very smart, which is because it is true. Once JavaScript ignores types, that's it. JavaScript always has to be backward compatible. So once we ignore types and as part of JavaScript, that's it. We can't unignore them back again because some old code will stop working. True? Yes. But I believe that when the need arises, we will find a way. Let's put types in, and then like a few years later, say, okay, we want to standardize types, and we want it to look like this. We will find a way. TC39 will find a way. What exactly it is, I don't know, but obviously there is. And then those are, type annotation good, but why stop at ignoring them? Okay? As long as we're doing types, let's do them all the way. Fully embrace TypeScript syntax, build a type system of our own, do runtime checking, optimize performance based on types, all good and valid criticisms. Okay, so why not fully embrace TypeScript? Let's go all the way. And this is very, very important. I mean, everybody's using TypeScript. It's the de facto standard. Why not use it? Okay, TypeScript is developed by Microsoft. Okay? Microsoft are also part of the standardization of this proposal, by the way, and from my point of view, this is amazing. But TypeScript itself is developed by Microsoft. They're not done innovating. They're still creating versions with more and more type stuff in it, which makes it better and better and better. Innovation will be hampered if we stop here. If we freeze here, that will stop innovation. TC39 is much, much slower at doing stuff, and that just will kill the evolvement of TypeScript. If we do TypeScript, that will monopolize TypeScript, but there are other type systems out there. Flow is great, Hegel, and probably others. Okay? If we do not standardize, we end the monopoly and let other type systems flourish, and maybe there will be other things that are better than TypeScript. And TypeScript is huge, huge. I mean, standardizing it will probably take 10 years, 15 years. It'll never end. So even if we wanted to, it's not something that will probably happen. Okay, so why not build a type system of our own? And there are two camps here. Let's make it simpler and let's make it cleaner. Oh, TypeScript is too complicated. I have the master of this sitting here. Where are you, Dan Shapir? Well, TypeScript is complicated for a reason. TypeScript and Flow. They're complicated for a reason. JavaScript patterns are complex. We want this code below to show a syntax error. We pick an object and ask it for only the fields A and B to be there, and then do .c. That should be an error. This is very difficult to define in a type system. That is why TypeScript is complex. A simpler type system will just not be as useful as TypeScript today. If we define it, people will not use it. They'll continue using TypeScript and Flow. Well, TypeScript is too complicated. Let's make it cleaner. Haskell, OCaml, Reason, type systems that are really, really, really simple. They are. Okay, well, not Haskell, but they are mostly simple, cleaner, and have the whole power of TypeScript. So why not do that? And the answer is they're cleaner because they were built for cleaner languages, not for JavaScript. JavaScript is dirty. I mean, it's how much? 95, 25, 27 years. Not something that we can put a clean type system on. So why not? Okay, so that's why we can't build a type system of our own or use TypeScript. Why not? Well, let's go all the way. Let's do runtime checking. Why stop there? Okay. TypeScript, well, first of all, does TypeScript do runtime checking? When you write TypeScript, does it do runtime checking? No, because when transpiling, it erases the types. So today you're using TypeScript and you're not doing runtime checking, which is fine. If you think about it, Haskell, Java, all type-safe languages, C++, mostly type-safe, Rust, they do all the type checking at compile time. They don't do almost any runtime type checking, almost. So all the languages don't do runtime type checking. Having said that, TC39 suggested, maybe for parts of the proposal, doing some level of runtime checking. We're looking at it. And the last one is let's optimize based on types. If I know that foo add is getting 2 numbers, then I can make add, the function add, be much, much faster. There's a whole thread by Matthias Beinens, I hope I'm saying the right. He's one of the V8 developers. He knows performance, he knows JavaScript runtimes. He said this is not gonna work, not gonna happen, and he has a whole thread on Twitter on that. Please read it, it's very technical, very good. To summarize, wow, okay. Why types? They complicate the language. Because the community wants it. We've seen the graphs. Types are good, but why not continue with TypeScript tooling? Let's stop the tooling addiction, please. Mend the rift between JavaScript and TypeScript. Oops. Stop tooling being type to TypeScript evolution. And TC39 should be part of defining what types in JavaScript are. And standard, okay, so let's do type annotations, and let's embrace TypeScript all the way. No, it's just too big, and we need to continue evolving. Build our own type system? No, because it's very, very complicated, and if we try to make it clean, it won't work for JavaScript. Check runtime, go to Twitter on thread on why it won't work. And optimize using types, go to the Twitter thread on why it won't work, and check runtime. Well, no languages does runtime checking. Okay, so we've dealt with the criticism, valid criticism. Let's start with the what. What exactly is the proposal? And as I said, this will undergo considerable change. This is just the first draft. I don't know what the end result is. Okay, let's go like piece by piece where type annotation syntax space is, what will be ignored by the JavaScript runtime. As we've seen, functions, we have the type annotations for the variables and for the return value. But this is important because, okay, JavaScript needs to ignore the type annotation, right? How? How does it know where the type annotation ends? This is interesting. And what we've come up with is an interesting one. Like, if you think about comments, how does the JavaScript know when a comment starts? Easy, /star, right? How does it know when it ends? Easy, */, okay, comments. But what about syntax annotation space? Does it look for the comma? That's one option, but what if the type annotation itself includes commas? Okay, for example, this type annotation, pair number, comma number, has a comma in it. So what do? The answer is interesting. What we thought of, it may change. We look for the comma, well, generally, but if we see braces or curly braces or parentheses or square brackets, if we see one of those parentheses, we start counting pairs. So we balance the pairs and ignore whatever inside. So once JavaScript sees that less than, it will ignore anything until the larger than. And obviously it will count the less than, so the parentheses will match. That is how we believe type annotations should be ignored by the JavaScript runtime. And this will allow continued evolution of the type annotations without breaking JavaScript compatibility, because anything there, we can do whatever we want. TypeScript can continue to evolve. Flow can continue to evolve. We can have other type systems like Hegel and others that will probably flourish once this proposal, if this proposal is accepted. So this will not hamper them because they just have to follow this rule. But some TypeScript and Flow types will not pass this rule. Let's ignore where. So what do? We change the TypeScript code and add parentheses between, like, any type in TypeScript. I tried that, okay? You add parentheses around it and it's valid. So some TypeScript code will need to be changed for this proposal. So we just add parentheses. This is probably going to be a code mod or anything, like Microsoft and Facebook, Meta will write a code mod that will change your code to be valid for this proposal. Okay, so we saw that. Variables, obviously, will be type annotated to define what their types are. Types, type something equals something, both in TypeScript and Flow and Hegel. This is valid, and this is the type annotation space that will be ignored by JavaScript. Interface, never like that. Why not just have types? Type equals, but whatever. So interface, the name and in curly braces, whatever is inside will be ignored. Class properties, okay, annotated. Generics, obviously, very, very important. We can't have a type system, modern type system today without generics. So the thingy there will be supported. Importing and exporting types. This is supported by TypeScript and Flow. Using export type and type inside will be totally ignored by JavaScript. But there are some problematic type annotations. Let's talk about them. Casting. TypeScript and Flow have different casting syntaxes. TypeScript uses as type, and Flow uses this parentheses and colon. We need to figure it out. Accept both, accept one, whatever. We need to figure it out. Generic function is invocation. This is valid TypeScript. Unfortunately, it's not valid JavaScript, because JavaScript, thank you, it will say do something less than number, larger than whatever. Okay, so this in JavaScript will be treated as less than and larger than, and TypeScript knows it. They know that this is a problem. They have accepted that this is a problem, and they have a suggestion like add the 2-colon thingy over here. Okay, so they are suggesting to change TypeScript to conform to something that TC39 can accept, and this is great. This parameters, it collides with another proposal, so this is up in the air. Declarations, theoretically they're not in TypeScript files, they're only in DTS files, but some people think that they should be in JavaScript, we don't know. Function overloads, we don't know what to do with those. Functions without bodies, how do we deal with that? We don't know, we need to think about it. Abstract classes, adding abstract before, do we want runtime semantics for that? We don't know. Member modifiers, that it's smack in the middle of the syntax, no curly braces, no colon, no nothing. Oh, like public, what do? We accept these words, these keywords? We don't know. One suggestion was add in sigils, so %public, %read-only is like everything with % will be ignored. This will modify TypeScript and Flow a little bit, but they're open to the suggestion. TypeScript subset will not be in the spec. Enums, namespaces, and parameter properties will not be in the spec. Why? Because those are the only features in TypeScript that don't just erase the types, they generate JavaScript. They generate code, and that is not good. Even Microsoft today has no new features in TypeScript that generate code. Okay, all of it is type erasure. So they're willing to do that. So, and this is, by the way, if I remember correctly, a recommendation by TypeScript. Stop using these. Definitely namespaces, I'm not using them. They will not be considered for the proposal. And JSX, well, it's not part of TypeScript. I really want it part of the standard, but definitely not in scope for this proposal. The consequences, if this proposal lands, no more transpilation of TypeScript and Flow. With real browser ESM, we will be fine. We can finally remove all tooling. We'll still be checked by third-party type checkers. Slow convergence of incompatible TypeScript Flow to the new syntax. Tooling will become much simpler, and other type systems will be experimented with. But it will take time. It will take years until this proposal, and if this proposal lands. But it will be worth the wait, I think. Thank you very much.